Hello, everybody. Welcome back to Math 100. This is section 6.3, the pH level and acidity as an application of logarithmic scales. This will be a brief section, and we will just cover just one topic on the pH levels, as you may have seen in chemistry. So let's get started in section 6.3. So the topic of this brief section 6.3 is the pH level or pH scale to measure acidity of various fluids or liquid, right? And notice here, typically the P is a lowercase and H is capital letter. It's kind of strange, but that's how they write that in chemistry. And so we will not argue with that, okay? So pH level, what in the world is a pH level? This is a level to measure, and it's actually a number to measure how acidic or basic a liquid is. And so the acid has to do with, sometimes sourness. It has to do, really both of these ideas have to do with the number of hydrogen ions. Okay, so again, we do not go into technical details of physics or chemistry, but you can talk about a hydrogen atom that has a proton in the nucleus and then one electron going around it. If that electron goes away, it becomes a positive ion. Okay, so that's called H+. In fact, let's go ahead and write this down. This is what I was talking about. Maybe I should just do this. Hydrogen atom. Okay, so you have H2 is what we call a hydrogen, as a molecule, but each molecule consists of one proton and then one electron kind of going around and around, okay? And so there's a little joke. A hydrogen atom came to another hydrogen atom and it says, hey, I think I lost an electron. And the other one says, are you positive? Okay, well, sorry. It becomes positive when you lose an electron, okay? And so that is called H+. And so H+, when a hydrogen atom loses an electron, it becomes H+. It's called an ion. That's an electrically charged thing, which is sort of like an atom, except one electron is lost here. All right, so H+. And that determines the acidic level of the solution. Okay, so the pH level measures the concentration of H+, the hydrogen ion, which causes acidity. But the concentration turns out to be very, very low, which is really hard to measure. And it varies significantly over a wide range, just like the earthquake intensity levels. Right? So for the water, this intensity level or the solution, the concentration level turns out to be 1/10 million. Okay, which is 1/10 million, 1 in 10 million, or you can say 1 per 10 million. And so this is written as 10 to the -7th. Remember, negative means you have this large number in the denominator. The denominator is 10 to the 7th. So 1/10 to the 7th is called 10 to the -7th. Okay, so this is a concentration of H+ in pure water. Okay, so water does have these hydrogen ions. The pH level is the number that follows the negative sign. Okay, so we define the pH level to be not -7, but just this number. Okay, that is our pH level. So pH is 7 for pure water. Okay, you see how it works? See, the thing is, I think from a mathematician standpoint, -7 is okay. But having a negative number in any kind of index is sort of not well liked, not very popular. So they decided to get rid of that negative sign and put 7 as the pH level. All right, now if the number gets bigger, 8, 9, 10, you're talking about, like, let's say if you're talking about -10, 10 to the -10 happens to be 1/10 billion. Right, and so that's a very little concentration level, and that makes the solution very basic. Okay, so the larger the number is, the fewer the hydrogen ions are in the solution, and that makes the solution more basic. The pH levels are between 0 and 14. Notice here 7 comes right in the middle. That's the pure water. Okay, and I have a little picture below here. This goes from 0 to 13. Now remember, this means 10 to the negative 13, which is 1 over 10 trillion. So these really don't have much of H pluses, whereas you know, these have lots of H pluses, but still not as much as you know. I mean, these are still small numbers compared to 1, for instance. Okay, so the lower it is, the more acidic it is. Okay, so the vinegar, for instance, typically has about 2, 2.5, 2.9, 2.9 being sort of a reasonably sour vinegar. And you can see vinegars here because it is acidic. Soap water, any kind of a detergent is, of course, required to you know, to wash off things, right? And what washes off things, as in soap and detergents and laundry chemicals and so on, is the alkalineness, or the you know, you talk about alkaline water, but it's the opposite of acid, and it makes the solutions basic, you know, base, right? And so the soap water typically has between 10 to 12 as its pH level. And by the way, the stomach is very acidic because your stomach has to digest food, and it does so by using very acidic solution, which is basically you know, hydrochloric acid. And so its acid is pretty strong acid, by the way, and that's 1.7, which tastes very sour if you could taste the stomach acid, which you never do unless you throw up. Let's not talk about that. Okay, so that is one application of common logarithms, okay, and in terms of pH levels to describe the acidity of solutions. All right, now what kind of other applications do we have of, you know, logarithmic scales? And let me just mention a few. I've already mentioned some of these things in earlier lectures, but brightness of stars. Okay, twinkle, twinkle. The stars vary in intensity of the brightness significantly. Okay, some of them are much, much, much brighter than others. And so the scientists, the astronomers, have found it useful to describe the brightness in terms of logarithmic scales. You know, 10 to what power is the brightness? Okay. Sound intensity. All right, so I've already written it right above this, but sound intensity is decibels, right? In measuring decibels. And so that's another way. I really don't have to write these things down because it's written here. Sound loudness or intensity, the star brightness, and that there are many other scales used in science that use logarithmic scales. All right, so that's it for 6.3. There is a quick quiz that you can take here and online if that is required for your section. All right, that's it for section 6.3. And next time we'll go into chapter 7. All right, I will see you later. Have a wonderful day.